Hello everyone, hopefully you guys enjoyed today's lecture. Let me quickly summarize what we've covered in this lecture. So first, we reviewed the course policies and deadlines. You should try to attend the discussion that is live, even though we will be posting asynchronous videos that walk through each video. If you choose to go through that option, I really recommend that you first sit down and try each problem before you actually watch the video. Or at least if we have like a quote mini lecture of a video, I recommend that you might watch that first and then work on some problems and then watch how to do those problems. It really helps if you actually are active in your learning, and you'll find that you'll learn the material a lot better if you do that. Also, you should try to get to know your fellow students and also ask TAs, tutors, and AIs, you should also get to know your tutors, TAs, AIs, and instructors as well. You should definitely be going to office hours and trying to interact on Piazza, helping out other students, who knows. We're all here to help you learn and also to make sure that this is fun for everyone. Other things we discussed in this lecture is number representation. So it's basically the concept of how do we represent numbers, including in different bases, also different representations that we have. Once again, everything is just a bucket of bits that we'll keep on iterating over and over in this course. So you should definitely realize that you should interpret things as you need to. For example, say I had a bucket of bits, I might want to interpret it as an unsigned number, which means that I only can represent 0 to however many bits I have. Say I want to add a sign in there, I might represent it as a 2's complement number, so then I can represent negative numbers as well. We also had another notation called bias notation, which you'll notice again in a later lecture in this course when we cover floating point, but it's very useful in the sense that we are actually able to now take a set range of unsigned values and map it to a new section of the number line, essentially. We are basically keeping the same distance between each value, but we're changing the actual range as a whole shift. In general, I like to say we add the bias because the bias is a thing that's negative or positive depending on how we're actually shifting it, but you might see it as subtracting as well. It just depends on the materials that you are reading, but just make sure that you read and see if it says that they subtract or they add the bias, because typically they specify this. Another thing is sign extension and overflowing. Overflowing is when we can no longer represent a value correctly, or we can no longer represent an arithmetic operation correctly with the bits that we are given. Typically, a solution to this is just adding more bits, though there are some techniques with 2's complement to determine if it has overflowed or not. Sign extension is another important concept where we map a smaller amount of bits to a larger amount of bits, and essentially we just take that sign bit for 2's complement, and we'll just copy that bit to all the new bits that we have. Sign and magnitude does not do that. That just takes that sign bit and it just moves it over, and it just pads with zeros all the other new bits that it has. 1's complement is very similar to 2's complement because it does the exact same thing for a sign extension. So hopefully you enjoyed this first lecture, and hopefully you've enjoyed this new format that we were trying out, because this is all new and an experiment, and just please let us know on Piazza how you're feeling about the class.